you can bet all the money you earned before. Or not all, depending on how many points each player has.
So we also have some of these. It's one of the famous ones is Who Wants to Be a Millionaire, except
we also have that.
It's in India, so it's Kaun Banega Crorepati, and a very famous actor used to host it. And there's the movie Slumdog Millionaire is also about that show. So I actually had started the video. Now I will see how it.
Introduce myself.
I think I can just put your name and
Okay,
title
do it as
in the editing. I can put
okay. Well, when discussing variable stars, first of all, we mean photometrically variable stars. That is, stars that change their brightness in time. Actually, all stars do change their brightness, for instance, due to stellar evolution. But such processes are slow, and you are not expected to detect evolution changes of brightness during your life. Only rare cases are known when we are able to detect such processes. Normally, during our life, we see stars that show faster variations due to pulsations, eclipses, spots on their surfaces, or other reasons. And these stars can change their brightness by several magnitudes. Remember that if a star varies by 1 magnitude, it means variation of the flux from it by a factor of 2.5. And so if a star varies by 5 magnitudes, it means that its brightness varies by a factor of 100. And that's a lot of variation. And we know stars that change their brightness even more. For instance, there is a nova, V1500 Cygni, that changed its brightness during a very short time interval of several days, from magnitude 21 to magnitude 2. 19 magnitudes.
Really?
Yeah, it's a lot.
Then was it in the Milky Way?
Yes, it's a Milky Way variable, and it was visible to naked eye at maximum. Many people saw it.
What year was it?
1975.
Okay. So I couldn't have seen it.
Well, you couldn't have seen it, but it was a spectacular process. I remember watching this star. I was a young postgraduate student, and we were at the Crimean station of Sternberg Institute, and one of undergraduate students there was the first guy at this observatory to notice this star. And many people were observing, and at that night, almost every dome of the observatory was turned to that particular part of the sky, and people were looking at it. By the way, the guy noticed the second magnitude star, the very bright star in the sky, and the other guys, professional astronomers, were asking about coordinates. They didn't take an effort to look at the sky and try to notice. So noticing even such a bright nova, well, it needs some skill.
2 magnitude, I think it should be easy if you just know the main.
Absolutely easy.
What constellation was it?
Cygnus.
Okay. So
there was even a poem written about this discovery by a famous Russian poet, Voznesensky. He mentions some postgraduate student in his poem, and that's me.
Really?
And he's mentioning me not very favorably.
Oh, wow.
And many years after that, I asked him about his reasons. He said, I don't remember anything. and we were in the theater, and he wrote on the theater program, "I never said anything against the postgraduate student." I keep it in my collection.
Okay. Coming back to variable stars.
Well, yes, we have to discuss the problem of variable stars. So, many people know about pulsating variable stars. They were among the first variables, except novae, detected by the mankind. About the year 1500, Mira Ceti was discovered, and it was discovered first presumably as a nova, and then it turned out that it appears, disappears, and appears again at the same place with a period of the order of 1 year.
Okay.
And then people began to detect eclipsing variable stars. Europeans discovered the first eclipsing variable star in the 18th century only.
Okay.
Well, actually in the 17th century. It was rediscovered in the 18th century by John Goodricke, and that was a great discovery. He understood the reason for the variation.
How long before they were discovered? What was the period when people did not know what, or were they classified as a pulsating star until then?
I don't quite catch your point. If you mean Mira,
until the mechanism for eclipsing variables was discovered, were they considered?
They didn't know. They simply didn't think about the causes of variability. They saw that the star would become fainter, and then John Goodricke found the period. He understood that the process was periodic, and he got the correct idea that there are actually two stars, and one of them goes in front of the other one in its orbit. He didn't detect the secondary minimum, by the way, but this star has a shallow secondary minimum detected much later.
Is it the Algol?
Yes, it's Algol.
So is it fair to call it a variable star because it's a variable? I mean, if you define star as a giant sphere of gas, or that wouldn't be a variable star. It would be a variable star if you define stars as what we see as white dots on the screen.
That's more or less what people think about when discussing variable stars, because we have several types of variable stars where the reason for variations is due to binarity, not necessarily eclipses. There are so-called dwarf novae where we have brightness of accretion disks in binary systems. The accretion disk gives a considerable part of light we detect from the Earth, and from time to time mass transfer through the accretion disk became stronger, and then we detect a considerable brightening, say by 5 magnitudes. That's the flux different by the factor 100. And such cases are not too rare. We know such cases. And again, here we have, in fact, we have binary systems. But of course, there can be variations of single stars. Take our sun. It's not normally considered a variable star, but it is a spotted star. And spots cross the solar disk due to sun's rotation around its axis. In several days, the spots cross the surface, the visible surface of the sun. And it was found that if a large group of spots crosses the disk of the sun, it is possible, at least from space, to detect the brightness variation. But the sun is not very heavily spotted star, and there exist stars with many spots on their surface. Such stars can show quite detectable, easily detectable variations.
We only have, for us, it's the sun, and the rest of them are so tiny. Do you think near the center of the Milky Way they have, or let's say there are people living on a planet, and for them they have their sun, which is reasonable, like one half a degree diameter, angular size like us, and then they have stars which are not point sized. They can probably see the radius through their eyes, like we see for, let's say, Jupiter. I mean, you can't see Jupiter by eyes, but maybe with a small binoculars or something like that. Or
Well, you can see Jupiter.
With your eyes?
Yes?
No, I mean the radius.
The radius? Oh. There is a historical anecdote about Carl Friedrich Gauss. He wanted to surprise his mother, and he showed her Venus through a telescope. And the phase of Venus was so that it looked like a young moon. He expected reaction like, oh, I never thought it's like a moon. But her question was different. Why is it in the opposite direction to what I see with my eyes? So she had excellent eyes and she could see.
That is not possible.
It is. Because Venus at maximum diameter, well, it can be detected as a crescent.
Yes, with a telescope, but not.
No, with your eyes. It's about 1 minute. It can be detected but the vast majority of people don't see it.
But when it's at the brightest, when it's near the Earth, then it's all when the crescent is when it's a crescent and it's near the Earth, it's too bright. So.
Well, that's the reason why most people don't see it.
But I did not know this. Maybe I can try it next time.
Well, try it if you have excellent eyes. Maybe you will see.
Okay.
Well, but just remember that knowing the fact, you can imagine.
Yes.
And some people after that historical anecdote would say they see it, but who knows if they see them or not. For instance, looking at Jupiter. Jupiter's satellites are fifth magnitude stars. And normally you could expect to see them with your naked eye.
Yes,
I don't see them.
One day I was sure I was seeing them, but my friends were telling me that I am hallucinating. But even I did not know if I was actually seeing them.
Well, if you take even a small telescope, you will see them easily.
Yes.
But for me it was interesting that our photographic plates kept in our collection clearly show if there is Jupiter in these plates. You can easily see satellites on the plates. They're quite discernible. It's interesting. I was surprised when I first noticed that.
Okay. Now I want to ask you about your history with variable stars.
Well, my history is very simple. When I was the first year student, I heard that there was a group of undergraduate students studying variable stars here in this department of the institute. There was a guy called Kovalenko who tutored these undergraduate students, and they came to that group, and after some attempts to estimate by eye with a magnifying glass to estimate brightness of variable stars, I was happy about that, and so the leader of the group, Kovalenko, told the boss of the variable star department here, Holopov, that he had not only me, but two students who wanted to continue on a higher level, and Holopov took us to his tutorship. And after 1 year, his boss, Professor Kukarkin, said he wanted those guys. And we were taken to Kukarkin and continued by him. And we were studying variable stars, and then we went to take photographs for Moscow plate collection to Crimea, and then we were engaged in studies of variable stars and globular star clusters. It's my second scientific interest for my whole life. So then around year 1980, Kukarkin was already dead, and I was told by my friend from my student time that it would be a right thing for me to become engaged in the work on variable stars here with Holopov. Kukarkin was already dead, and we started working with Holopov, and then after Holopov's death I became the boss of the project, and now we come to the times when the project of the general Catalogue of Variable Stars, well, is almost near its end, because cataloging variable stars becomes a very difficult task. People, well, space projects, ground-based automatic projects discover variable stars in such numbers that cataloging them in our manner, and the manner is thinking about each star individually, it becomes almost impossible, and very soon we will not be able to continue.
Okay. I did not know about that. When did you take over the GCVS?
Well, I started around the year 1980, and Holopov died in 1988. After that, I'm the boss.
Okay.
So that's already 33 years. And I think that now I am the boss of the project, who remains the boss for the longest time in the world, in the history of the project.
So do you see portals like VSX becoming the next?
Well, VSX is a very interesting project, but I'm not sure they will keep in pace with the new discoveries either, because when people announce 500,000 discoveries at once, and such cases happen now.
500,000?
Yeah, Gaia.
Really?
Gaia project announced 500,000 discoveries.
Variables?
Yes.
When?
Well, rather recently, several years ago.
How long did they observe for?
Well, for several years only. And so they didn't announce eclipsing variable stars because it's difficult. If they see one minimum, they don't know the period and they have to wait. But they discovered a large number of Cepheids, Lyra variables, other types of variables, and even just variables, not knowing what that was. So
was it manually classified?
No, it was automatically classified. And so far, automatic classification causes mistakes, and there are mistakes in their classification. But that's great progress, and very soon people will be overflown with these new discoveries. And since no one will be able to put all these data together, maybe, I don't know, I hope I'm telling something foolish right now, but maybe in the future people will discover the same variable star again and again and again, because no one will put the data together. I don't know. I hope that's not what expects us, but
doesn't the International Astronomical Union have a department for variable stars that can oversee this?
Well, actually, the project of the General Catalogue of Variable Stars in the 40s was the project of the International Astronomical Union. Nowadays, they don't support the project any longer, and they don't support the VSX project either. And by now, the IU even doesn't have a unified commission for variable stars. There are commissions for some types of variability, but there is no joint commission for variable stars. So our GCVS now is our project, not supported by the IU. There was one other case. There was the famous space project, Hipparchus. And they discovered, at that time it was a great discovery, 5,000 variable stars. And they suggested us to include all these stars within 2 or 3 months into the GCVS.
Okay.
And we told them, oh guys, it's a very large project for us to do it quickly. They say, well, we will pay. And they paid not a large amount, but a small amount of money that was distributed among people who did that project by us. By the way, discussing variable stars, eclipse and variable stars, I would say that a solar eclipse is also something of the kind. And it's a great event. Have you ever seen totality phase of solar eclipse?
No, annular.
Well, annular, I remember we discussed
yes.
that. Look at totality, it's something.
So now let us come to the Moscow Plate Archive.
Okay, it's interesting indeed. Actually, in Moscow, people started photographing sky with small cameras. Well, most actively after the year 1895. Before that, there were attempts and no more. But in the year 1895, Professor Blashko, not professor at that time, of course, the young astronomer Blashko, started regular photographing of the sky in Moscow at the observatory, which is now in downtown Moscow.
So Blashko, as in the Blashko effect?
Yes, the same guy, yeah. He started our Moscow plate collection. And they were observing with very small cameras, say with objectives like 10 centimeters. And then it was continuing till the Second World War. And after the war, a 40-centimeter astrograph was taken by the Soviet Union as a part of German operations. And this is the telescope that was used to take the largest part of our plate collection, including those plates Yashad Han was studying by us. These were plates of the so-called GA astrograph bought by Hofmeister for his observatory, Sonneberg Observatory in Germany. Hofmeister was very unhappy about this astrograph going to the Soviet Union, but he didn't feel sorry all the time. He just solved the problem very simply. He ordered 2 other astrographs of the same kind for his observatory. And this telescope traveled for some time across the Soviet Union. It was used at several observatories. But in the 1950s, Sternberg Institute established a new observatory in Crimea, just close to the territory of the Crimean Astrophysical Observatory. And it put the telescope there, and it was used there since 1950s to 1990s for taking photographs of the sky. And the total number of plates taken with this telescope, well, I'm now telling you from my memory, but I think it's 22,000 and a half, 22.5 thousand plates. And these plates have the size of 30 centimeters by 30 centimeters. They are large. And they cover the field on the sky 10 degrees by 10 degrees, 100 square degrees. And the limited magnitude at the beginning of the project was about 17.5 in blue light. It's a good limited magnitude. By the end of the project, the limited magnitude was worse, maybe by half a magnitude or even a magnitude, because the conditions at Crimean Observatory became worse at that time. You can see the lights of the large city of Simferopol from that place. And then, after CCDs started, the first thing the world community did was to discontinue producing photographic plates. Till now, you cannot take a CCD image of the field 10 degrees by 10 degrees on the sky. It's impossible. Why stopping producing plates, no one knows, but it was done. So after a relaxation period of, say, 10 years, people began to cover the whole sky with many images, CCD images, and nowadays, of course, we don't need photographic plates anymore. But the photographic archives still are important because they show you the historical sky, not recorded anywhere else. And so, turning to these plates, you can do real science. You can see something that will not show itself on modern CCD images because just the star changed its behavior. And also you can see asteroids crossing the plates. Well, you can see also meteors and airplanes, but this is not used by anyone. And also in Crimea, there are not too many airplanes crossing the plates. I spent several months of my life at the Maria Mitchell Observatory in the United States. And there, since the 50s, the air traffic was heavy. And so there are many plates with traces of airplanes. So we have all this collection, and some time ago we started digitizing it. We are not making very good progress in digitizing the whole collection because we are not rich. Americans are much richer and they can hire people to digitize the plate collection. By us, we digitize the plate collection ourselves. And we are asked to deliver scientific results. So if we spend several years just scanning plates, we will not give any scientific results at that time period, and that will be bad for us. So what we do, we try to scan a field and then study it and then make publications and then turn to another field. It was a good process till recently when it was quite possible after the scanning of a star field. We normally have several hundred plates per field. After we finished scanning a field, we could discover, say, 100 new variable stars and have a good paper. By now, the problem became not that easy because you discover 100 variable stars, but then you find that 95 of them are known. And it's much more difficult now to make a publication out of this than it was only 15 years ago.
Let me ask you about the drawers behind you.
Oh?
When we used to speak on video call, I thought the plates were inside those. But now I know that they only have some papers inside them.
Oh, these boxes are not for plates.
What do they have?
They have the Moscow Variable Star card catalog, started in the 30s of the previous century by Parinago.
But Sternberg Institute wasn't established until the 50s, right?
Oh, no, you are not right. Sternberg Institute dates back to 1930s, and Moscow Observatory dates back to the 19th century. And the change of the name from Moscow Observatory to Sternberg Institute doesn't change much in the life of the scientists. And Professor Parinago, already at Sternberg Institute in the 30s, was interested in variable stars, and he started compiling a card catalog of variable stars. Each card in this catalog was devoted to a single star in a single paper. So if a paper mentioned 100 stars, they would prepare 100 handwritten cards. If one star was mentioned in 100 papers, again 100 cards. And this card catalog became known to the International Astronomical Union, and its existence was one of the reasons for the IAU to decide that the project of variable star catalogs should be given to the Soviet Union, because they had already something to start this project.
Can you show me an example?
Yes. These are new variable stars here.
Can read no view. Oh. Okay.
By the way, let me see. This is my handwriting. This card was written by me.
Okay, I think after this we can go to the...
Okay. Labeled scanned, and there are how many boxes? Oh, something about 10 boxes. Yeah. Each box contains something like 12 or 14 plates. Well, do you want me to show you the plates?
Yes, anyone.
Well, we'll have to take them.
So it says Cephia,
and then
Syria A.
Yeah, Sirius A means astrograph, and AC was a very small Sirius taken with an astrograph in Zvenigorod. There is about 100 plates only. Let's go here.
So these are the coordinates.
Yes, and these are the plates.
There are no very prominent stars here.
No.
Nothing I can quickly identify.
No. Here's the plate number, the coordinates, the date, everything is written in Indian ink, as they say.
Why Indian ink?
Well, this black substance is called Indian ink.
Is it because of racism?
No, I don't know the reason.
Might have been produced in India or something.
It was invented in India, I think, many years ago, as many things were invented in India. Nowadays, during the COVID situation, a very intellectual guy known by almost every Russian, Anatoly Wasserman, he's advertising vaccine against COVID, and he says vaccination was invented in India 1,000 years before Christ.
It's a non-Indian who said this.
Non-Indian.
That's very strange. We hear such claims from Indians all the time. For example, in Mahabharata, one of our epics, poetic epics like Homer's Iliad and Odyssey.
I know.
So there is this concept of there are so I will just pause.
The plate to the sky, and it was exposed for 45 minutes.
I'm quite impressed by the 45 minutes exposure, because I mean, when we tried as amateurs, even to get the telescope to track right for 1 minute is a challenge. So even in 1 minute we can see that it's not tracking at the exact speed, or if the not
of course. But what was done? There was a special telescope attached to this big one, used for guiding, and you had to look into the eyepiece and correct the motion of the telescope.
Really?
Yeah.
Manually?
For 45 minutes you had to be attentive.
Wow.
And after that, the end of the exposure, you take the plate holder and you put the plate in the box, and then in the morning you go and develop the plate. You develop the plate, dry it, and then you can use it for looking for variables.
Have you ever done it?
Yes, of course. Many, many times. I was observing there for a long time, and I was taking plates and developing them. And there was a case when I noticed an extra star on the plate. I had a single plate of that night, but it was 15th magnitude star, and I was looking through the whole small number of plates we had there, and it was nowhere on these plates. So I had to take another picture. And the moon was large, and it wasn't very easy to take this plate. I specially woke in the early morning, took this plate after the moon was down and the sun came up. And I developed this plate. I was very tired, and I looked at that plate and I noticed that the star moved slightly, but definitely. I didn't think about this. I went to sleep again. And when I woke, I already had an idea what that could be. It was Pluto.
Then how was it not on previous plates if it was moving?
The previous plate was for previous year.
Okay. And
then, after all this mess with Pluto, it was crossing the plate slowly. You can see it on each plate, of course, now. And next year, other students had to go to the observatory, and I told them, don't discover Pluto. It was discovered by Tombaugh, and it was discovered by me. You will not be the discoverers. And the first thing they did when coming, they discovered Pluto and made a great mess of this. I spent about 1 day estimating plates, looking through these plates, and 1 night for taking the second image, and it was all. And it took them 2 or 3 days to understand what they were seeing, but they did it. They understood what it was.
Now we are looking at the plates up close, and it's kept on a box which has lighting inside, so it is backlit, and you can see that the stars are really tiny. So even the smallest of stars, they have been captured by the plate. Now I'm going to use oh no, I can't turn. So this way, with the help of a magnifier, we can examine the plate in a much better way, I guess. One of the, I would say, differences between, well, I don't know why it should have, oh no, this is a refractor telescope, right, Professor?
For decades we used this kind of magnifying glass.
Doesn't it hurt the glass?
Well, this was sold at shops for photographers. And so we used to buy such lenses, and they are nice.
One of the things I like about refractor telescopes is that you don't get the diffraction spikes, the four
No, you have other flaws. Look at the corners. They are very bad. The corners are extremely bad. This was the first large German astrograph, and its corners were especially bad. Later telescopes of this kind were much better. This one wasn't good. You see, the stars are not round.
They look like comets.
Yes, and this defect of photographic images is called coma.
Do you have chromatic aberration in this?
Well, of course, but it's not that strong, but it exists, of course.
So if you take, could you have slight shifts in position if you take, no, I'm
Well, there can be distortion between red and blue stars. There can be differences. Sometimes you guess that the star is not ideally focused, while others are focused well. And that normally means that one of the stars is red.
Very ironically, this feels like microscopy instead of telescopy. I feel like I'm looking in the microscope and at bacteria.
Well, actually, people were using microscopes. In Zonderberg Observatory, they had special microscopes. I think we had one somewhere. Just where it is.
So what is the purpose of this room?
This is the scanner room. That's the scanner. It was something like 10 times cheaper. Those were bought by the university, and this was bought by our team.
So it is not a special scanner for the plates?
No, it's polygrammic, for polygrammic purposes.
What is it?
For producing books, booklets, and here you have a special additional device to scan transparent materials.
Oh.
This deck is just for transparencies.
And what DPI do you scan it?
2400. It's good resolution indeed. And you can put the whole 30 by 30 centimeter plate here. But normally we make two runs in scanner. One half and the other half.
I did not understand.
Well, if you scan the whole plate, the volume of the file will be so large that it will overflow your memory.
Okay.
And so normally we scan it in two halves.
Okay.
The northern and the southern.
Do you manually stop it, or does it? Can you program?
It's programmed.
Okay.
It's programmed.
Let me take a look at your poster here.
This is very old. This is just when we started.
So I will walk you through the software and analysis part of it now.